hope that is working. First, you see that I changed my title slightly, but significant, I would say. And the other thing is that I will not talk about Semantic Web. I will talk about what we can do, and this is all of us, hopefully, to make our data in a way accessible to these techniques. Yeah, because it's one way that you say, okay, we just push everything to the technique and Semantic Web will solve all our problems. I don't believe in that. You know, we have to make our work, our life in a way, change it a little bit, that this is really data which can come into this whole general environment and be part of that. And this is what we started with this PDF. If you submit a PDF, we will not be able to get that into Semantic Web. And if you don't provide the metadata, nobody else can do that for you. And therefore, there's always this problem of having technical solutions. If then the people don't jump on it, then these will be going nowhere. Starting a little bit, this is small, I know, and it's not so important. You can read that on the website as well. But I would like to introduce at the beginning why my slides are not Douglas Connect, but OpenRiskNet. We have an EU-funded project which is really trying to do that, trying to bring data and software together, that they understand each other in a way that not everyone has to build converters or bring it back into their own database. Yeah, I know that this is, at the moment, this collecting of data from everywhere is very often done, and it's very useful because then you have it in your own system and you can use it. But then the next person has to do it again and again and again. We try to do that by these standardized ways. I don't talk about standards, I talk about a standardized way because I don't believe in standards, because nobody's using them. This is all an open source infrastructure, and I really invite everyone to participate as an associate partner in that, because we really want to have all of them, all stakeholders in that, and then bring something together which really is for everyone and not for me as a specific person. This is a team. We are 11 partners in this project. Douglas Connect is the coordinator, but there are many, many people in Europe, and we want to extend that with a lot of associated partners, and I think we are on the right way, and we saw many interesting things. This is just a nice slide. As I said, you can look that up. It's the question what we want to do, and here it's the harmonization, standardization, and so on. Build an infrastructure which you really can then use for your own purpose. For whom, I just said, more or less for everyone, hopefully at the end, researchers, risk assessors, regulator, but perhaps also for the informed public at one point of time. And this is to then have really here this infrastructure for risk assessment or safety, safe by design methods. This is what we started, and now we go a little bit into our daily life today and how I see that and where I see the problem which we want to solve. Yeah, and as I said, I think this is something where everyone has to think about his own work and say, yes, this is what we do at the moment. Yeah? Most of the time, the data is used once. And I think we hopefully change that by all these public available data sources. But at many things, especially in academics, are just somewhere on a local hard drive, and people starting to reproduce the data over and over again. I think this is even worse when you think about computational things, because there it's much easier to write your own software than to understand the software of somebody else. And therefore we reinvented the wheel over and over again. And this is also done with these expensive experiments. Yeah? Why should we do the same experiment again? Why we do it at the moment? Because we don't know that it is already existing somewhere, because we don't find the data, or if we find the data, we don't trust it because it doesn't have the metadata assigned, but we really can see what is done and is that something which is high quality data? Okay, it becomes better. Now most of the projects are forced to publish that in a public available data warehouse. But here also, when we now want to find the data, you have to go to each of these sources and type in your chemical name, and then you find something or you don't find something. But this is work of a couple of days to really say, okay, I searched every available source and this data is really not available. Therefore, I have to do it again. And then we need to think about what is, now we found the data, what do we have to do? There is many times we now go in with each start of the project. The first year of this project is to reintegrate all the data which is already available and then do that over and over again to adapt it to my new database. And I have one nice example. TGA is probably one of the best known sources. And I just clicked, this was really a 5 minutes exercise. I just looked around. This is the original data source. And then I thought about the project I know, and then I tried to find it. Here, this is something which is based on, I like that because it gives you a little bit more information, toxicates. But then you go on, and then it's in the DIXA, which is a European project. It's in TopCap. It is in biostudies, also European. And then it's in Tosca. And I think whenever you think, if you go into European projects which have a common database for this project, you will probably find TG Gates in there. Nobody knows from when this data is. Nobody knows how it was curated. Is it just taken in there? Was there something changed? Which version was used? For TG Gates, I think this is not so problematic because it is a relatively stable data set. If you think about ToxCast, this is definitely different. We have the different phases. We now have a third phase for TOX21. If that is somewhere in one of these databases, you don't know if that is really the newest data, is that something which is 5 years old. Good. How do we use data? Okay. That is why, okay. Here, we go here. Yeah. And what now? We have now all these data sources. What are we doing with that? And the thing we are doing is that we download these files and then we reformat that into what we want to have. And in that step, we also lose these many informations. And we also have then a static version of that, which we downloaded at one point of time. And when there are updates, we will not see that. I was thinking about this whole concept here, what that means. But in principle, when you think about this formatting in that, it looks for me like these power adapters. You have for European and American and British. And then you just combine these power adapters to get that huge thing because you always have to reformat that. And in each of these steps, you lose, throwing around, you lose information which is gone forever. And I'm coming from the drug design and computational chemistry, and there are so many tools which all use different formats. And whenever you go into one of these programs and go out, everything before that is lost because the format doesn't allow you to bring in data which is already in the input, because the output will determine what is in the data file. Okay, why is that slowing down science? One thing is, okay, we do that manually. We go to all these different data sources and then download them. We are error prone, because there is this nice example of CAS numbers. Whenever somebody tried to use CAS numbers in Excel and then saw, oh my God, now it's a date because it interpreted as a date. And there is no way to go back And when you have thousands of compounds in there, and you will probably end up with 2 days, find them in your top 1,000 compounds. Yeah, we had that. You have to go through different databases to really find that. You don't know when the database is updated. You also have to then parse these data somehow. And if you think about the Tosca, the downloadable version of it, it is consisting of 20 different CSV files. What does this all mean? And it has to be re-implemented. And probably everyone did something like that all over again to get that, and then even just for a single language in different groups, but also then for different. Yeah. And on the other side, the data will not improve over time. Yeah? If you find a problem in the data source, you will correct that. But nobody will see that. And therefore, people will have to do that over and over again. And if you want to publish that, then you have to agree with the original producer, and then you have to upload everything again. Okay, therefore, our approach is a little bit, or not different, but what we would like to propose is that we are investigating time in building these APIs. And I know that many of you who provide databases already have APIs, and this is very nice because that gives us a very nice starting point, but we have to then also get them in there in a better way. Yeah, the advantage is we can use it in different ways. You can use it in a browser on the internet, but you can also consume that in workflows, and I will show some examples of that. And you can then filter that and search many things at the same time when they are somehow harmonized. Yeah, I will show that with our APIs which we created, and this is also a little bit different to what normally people are thinking about, because when you think about databases, then these have APIs or they don't have APIs. And if they don't have, you are more or less screwed. Yeah, and then you have to think, how do I get the data? And then you type in your words in the web interface again. What we want also to do is that we will help other people to provide their data with APIs. And this is why we've chosen these kind of existing open available data sources just as examples on how this could look like. Yeah, these are at the moment, because we did it based on these downloadable data files, which is a starting point, but it's definitely the question, can we do that and go to the newer, like the dashboard, new and the updated versions, which are then directly integrated. And as I said, we hope that more is coming. Good. APIs, just a very quick view on that. APIs just have different endpoints. We define most of the time 3 endpoints, that we have an assay, that we have a compound kind of thing, that we have an assay, and then we have the results, just to be able to go in there in a standard way. These will look different for each different database, but at least you know that you have these endpoints. And then you can already say, okay, I want to have all the compounds in this database. There's just a little bit more in there. We have here filters that you filter for a specific compound, like on the ID, but this can be extended, and this is a question how we then offer that and also make others to understand what this API really offers. You have the 3 main parts, but then these main parts definitely have different entities in there, but also different filter variants. And where should that all go? Our idea is really that we have these data sources on the lower, and people can provide their data sources in a specific way, which they expose their data, and then we, the Open RiskNet project, provides this interoperability layer, where all these data sources will come together in some kind of harmonized way. You can then look at that with our Data Explorer, for example, or other web-based tools, but you can also go into the model. This is this Data Explorer which we have. It's called Data Explorer because there was a Windows Explorer for files, but it is more or less just showing you the data in a form where you can get a very quick view on what is available, what is in the data set. You can search for different compounds. Yeah, you have different searching and browsing tools in there that you can say, okay, I have a keyword search. I can display which columns I want to have. It's for a very quick view, it's nice. It can show you the form, what is available. You can search through different databases at the same time using this keyword search. But at the end, it's really more for the first entry into this database and say, okay, what is available there? What are the compounds which I find in there, and so on. The more interesting point is then that the same calls, and this is perhaps what I should mention, you have here, when you then search for that and find something which you are interested in, this tool will also give you the API call, which is used to generate exactly what you see on the screen. And then you can go into other tools like here, I think that is a Python script, where you just have here the request call, exactly with the same parameters as you showed before, and then you have this data in there. And then you can go into multiple workflows that you search or that you analyze it, that you normalize it if it's really raw data, and use here in the Python or R script. You can also use R, and then you have all the different tools available which you then can use for analyzing. And I think we heard already very many of these nice tools which end up then in some kind of heat map for these data sources. And this is something I would like to understand at one point of time. What you see here is a little TG Gates data. The first one is human in vitro, then it's rat in vitro, and then there is multi-dose rat in vivo, and I don't see anything in there, at least no correlation between rat and human, and not between multi-dose in vivo and single-dose in vitro. I'm not sure how we can do here this extrapolation, but probably there are people who are much better than I am. Okay, KNIME is the second example. I like KNIME because it's much easier to get in there, and one goal is really with this whole is that it makes it easier for people. Yeah, KNIME, I don't know who knows KNIME, but in principle, KNIME is just building this kind of workflows where you do a lot of things, and this is what you need to do to get our ToxCast API into KNIME. Looks complicated, it is complicated, but in principle at the end we will provide just one node you can access. And then you have all the compounds of ToxCast in your workflow. Then you can combine, and this is just making some similarity search for compounds I'm interested in. And again, at the end you can end up with some nice workflows and heat maps to show active profiles in ToxCast. Even simpler, we can also build tools around that. This is what Barry already mentioned, the Garuda platform, where we now have these two APIs in there, where you can do exactly the same thing, that you look for TG Gates data for specific human liver, for boric acid, for example, and then you have that in there. Now you can combine that with with system biology tools to do whatever you want to do with it. Okay, this was the starting point. Until now, I never talked about semantic. Yeah, this is just a nice way to get data from different sources, but there was no semantic at all. Yeah, because still you have to understand what this data is. You have to look into these different columns and say, okay, this is the compound list I have to do. Therefore, we have to be a little bit smarter and now try to explain what we have there, the tool or the database in a way. And this is just a very short overview of what is needed to understand data. You need to know what type this service produces, and in this case it would be a data source. You would probably need to group that in some area. You could say, okay, this is chemistry, chemoinformatics, or toxicology. The idea here is really to have it broad and make it available also to related fields. And I hope that at the end this might be working for drug development or the combination of toxicology with drug development or even translational medicine. Bringing them together, and if you have here the grouping, you would know, okay, this tool, this data is, for example, from patient polls. And then you have here in principle 3 things you have to describe. This is the input, then what happens in the servers, and then you have an output. This is what I already said. We have here some kind of grouping where it comes from, and now we get a little bit into semantic. Whenever you say, okay, this is from the field of chemistry, then you should probably at one point of time attach ontologies to that and say, okay, then we always know that this is cheminformatics and chemoinformatics is the same thing. We now have an ontology term for it. What I want to concentrate here on, because we are talking about data, is this part. Now I have here an input, an action, and an output. And in principle, when you think about that, I just jump over that, you can also do that with data in a similar way that you really have these 3 things. You have a compound. With this compound, something happened, and what happens to this compound is described in the assay, and then you have some kind of readout. Or in the transcriptomics, you have more of the sample, then you have a probe, which you test on the sample, and then you have fold changes, for example. This general theme of this input, then action and output, I think this applies to hopefully everything, and therefore we can start to build on that. As I said, it looks like what we had already in this data explorer. We had compounds, we have assays, and we had results. What now is important is that we really identify or describe what is in there. And when you think about efforts, most of the efforts we have for annotating data, it's mainly on the data point level. You say, okay, the sample, or this assay is based on a cell type, which is HEPA G. We had that before, and then you annotate HEPA G. What I'm talking here about is that we annotate that it is a cell type. Now that we know in this column we have a cell type, because then we don't need to know the exact order of these columns anymore, and therefore we don't need this standards, because somebody can fill in another field here or just reshuffle this whole thing, and we will still know what it is because we describe our data. Now we don't describe the data point, we describe the format of the data. And this is where I hope that people jump on that and say, okay, this is a little bit of an extra step for each source. If it's something which is common, we can define standards, that people use the same columns. But in principle, that is not needed. If somebody has a new idea and needs another field, then he just adds it, but he has to describe it. And this is in principle all I want to say. Here we are, but it's clear that at the end we will do that and annotate that. But when we have a starting point, when you describe your data in a form that we understand that, we can probably provide that relatively simple also automatically. But we need to have that structure first, because otherwise we will end up with a huge mass of different data types. And I know labs where each person used his own data format and they were not talking to each other. And then you don't have even interoperability in the lab, not talking about sharing that with the public. Okay, quickly why I think this is important, because now we can build interoperability. Yeah? We can have algorithms which then look automatically for data sources. Yeah? Based on the ontology, the algorithm can say, I need data. I need specific data, like a log P. Can you find me log P for this specific, for this component? But even more, yeah? If you then build the training model, for example, for a CUDA model, now we have the algorithm that's built the model. We can now annotate that, and this should be automatic because this is annotated, this is annotated. We can build here an annotation, a semantic annotation for this model, which can then be producing a derived data set or a predicted data set, which is then automatically also annotated. And in this way, I also hope that this work you have to do to annotate will show here directly a large improvement and a nice outcome that you see, okay, here we get a prediction, and with this data set which is produced, we will have all the annotation which is needed, and then you can just upload it. Okay, that was everything. Acknowledgement is more or less the project, and I hope that you are interested in joining. Thank you.